My name is Thiago Viegas. I will be doing a presentation on Markov chains in the Google PageRank. This is for Math 387 Advanced Linear Algebra. So let's get started. First things first, what are Markov chains? Markov chains are a mathematical model that are used to describe the system that transitions from one state to another based on probabilities. The best way to explain this is, in my point of view, is to use an example. So let's suppose you're a Drexel student and you have a dining plan. You eat every day and the same 3 meals: salad, fried chicken, or pizza. Let's say you had a pizza. A Markov chain would use your current state, having a pizza, to describe the probability of what your next meal would be. In this scenario that I created, there's a 50% chance that after you eat a pizza, you're also going to have a pizza, and a 25% that you're either going to have a salad or a fried chicken. Another way to represent this Markov chains besides a graph is by using matrices, where the columns correspond to each of the states. As you can look at a matrix, you see that all the values add up to 1, which are corresponding to the probabilities. So, what is this useful? Let's say you had a salad today, and you want to know the probability that you eat a pizza either tomorrow or in 3 days or in n amount of days. We can use the matrix that describes this Markov chain to calculate that probability. So in this scenario, first column indicates salad, second indicates pizza, and third indicates the fried chicken. We can grab this matrix and multiply it by the vector that indicates the current state to get a P1 value, which will be the vector that indicates the probabilities on the first day. So you had a salad, you multiply by the matrix, you get this first column, which indicates that you have a 50% chance of having a pizza. So what about 3 days from now? Well, basically P1 is A times P0, and P2 is P1 times this vector P0, which is basically A times P0. And we can also obtain P3, which would be A cubed times P0. So if you do the math and you calculate, you end up getting that A cubed is this matrix here. You multiply by the P0, and you get this corresponding vector. So how do we move to n days? So as we have seen in class, a matrix A is equal to P times B inverse, and we can just A squared will be this relationship P times B inverse times B inverse. This P inverse and the P would cancel out, and we'll end up with P times B squared times B inverse. If you do this n times, the P's inverse and the P's will gonna cancel out n times. So you're gonna end up with P times B n to the power of n times P inverse. So how do we find this B matrix? Well, we can just use the Jordan canonical form of the matrix in this case, and for all Markov chains, there's going to be an eigenvalue of 1. In this case, you're also going to have an eigenvalue of 0.5 and an eigenvalue of 0. You get this diagonal matrix. If you use these eigenvalues, you can also get the eigenvectors. In this case, for an eigenvalue of 1, you get 1, 2, 1, negative 1, 0, 1 for 1 half, 1, negative 2, 1 for 0. You create your P matrix using those eigenvectors, and you can also calculate its inverse. So now that we have that, we can put it all together and get a formula from A to the N. And if we want to know any of the probabilities of any of the possible states, we can just multiply this by this A to the N matrix. So how's this useful besides this? So a very known application of the Markov chains is the Google PageRank that was developed by Google to rank web pages based on their importance. The idea of the Markov chain in the Google PageRanks is that pages are states, and the links between them define the transition probability. So basically, they use this number of links from one page to another. It's like, let's say you go to Amazon.com. How many links from other websites there are to Amazon.com? If Amazon.com has a lot of websites with hyperlinks to it, that indicates that Amazon is a more important website. So Google will boost it and put that in a higher priority on its search engine. I believe they changed the algorithm over the years, and it's not the same nowadays, but it's still a nice application of the Markov chains. So that's it for this presentation. Thank you for watching.